question is, what volume of oxygen will be left unreacted when a mixture of 100 centimeter cube of hydrogen and 200 centimeter cube of oxygen are exploded in a hydrometer? Now, we have to write the balanced chemical equation. Now, when hydrogen, remember I said hydrogen is a diatomic molecule, so anytime you write it in a chemical equation, it must carry subscript 2. So hydrogen reacts with oxygen, so to give what? So to know what you will get, so you have hydrogen and you have oxygen. Now, what is the valency for hydrogen? 1. What is the valency for oxygen? 2. You can watch the video on how to write simple balanced chemical equation. I've already done video on it. So now, crisscross. So 2 is going to H and 1 is going to O. So the product will be H2O. So that means hydrogen reacts with water to give H2O. So we have to balance the equation. So in balancing the equation, how many moles of how many hydrogen do you have here? 2. How many oxygen do you have here? 2. So this is H2O. Excuse me. So how many hydrogen do you have here? 2, and oxygen 1. So like I said, start with the highest side, with the highest atom, and balance hydrogen before oxygen. So hydrogen is 2 here, is also 2 here, is balanced. Oxygen is 2 here, but is 1 here. So how to balance the oxygen? You put 2 here. So that means as oxygen is balanced, hydrogen is now 4. 2 times 2, 4. So you just have to put 2 here. So everything is balanced. You can watch my video on balancing of chemical equation to understand better. So now this is the balanced chemical equation. So now to the question, what volume of oxygen will be left unreacted when a mixture of 100 centimeter cube of hydrogen and 200 centimeter cube of oxygen are exploded in a hydrometer? So if the question did not tell us what volume of oxygen will be left, so I can find which one will be limiting reactant out of these two. Is it oxygen or hydrogen? Because if these two should react together, they will give you this. So now, if this is in real life, if we mix hydrogen and oxygen together, one of it will finish first, like an ingredient. If you are cooking a rice and if your salt should finish, that means you can't continue with the rice. Because if salt is not there, your ingredient is not complete. So now, if salt should finish, then the salt is the limiting reactant, meaning is the one that will delay the product. So now, which one will finish first if you mix these two together? How can we know which one will finish first? Then, and that is the limiting reactant, is the one that will now determine how many of water you are going to get. So now convert these two to mole. So we use their mole to know what we will get. Remember, this will be 100 centimeter cube divided by 1. So watch my video on the method I'm using. So now 1 mole of anything, so that is 1 mole of, this is hydrogen, H2. So 1 mole of hydrogen will contain 22400 centimeter cube of hydrogen. So that centimeter cube of hydrogen will cancel out. So I will have 100 divided by 22400. 100 divided by 22400. So that is 0.00446 mole of hydrogen. So now what of oxygen? So I have 200 centimeter cube of oxygen gas over 1 times So 1 mole of oxygen gas will be 22400 centimeter cube of oxygen gas. So this will go. So that means this will give us 200 divided by 22400. So that is 0.00893 moles of oxygen gas. Now we need these two here so that you can see what I want to do. So to know the limiting reactant, so I've converted the 2 centimeter cube to mole. So that means I will have this for oxygen, for hydrogen, and this for oxygen. Now what is the coefficient of hydrogen here? 2. So divide this number of mole by 2 is equals to what? What is the coefficient of oxygen here? 1. So just divide this by 1, then it should remain the same. So divide this by 2. So we have 0.00446 divided by 2. So you should get 0.00223 moles of hydrogen. So this is the lowest mole. That is, this one is smaller than this mole. So the one that is smaller is the one that will finish first. That means in this reaction, hydrogen will finish first in this reaction. So I only solved this in case the question did not tell you which one will finish first. So in my question now, this is limiting reactant, but they mention it in question. So if you read the question again, the question says what volume of oxygen will be left. That means will be left unreacted when a mixture of this. That means the question have already told us that hydrogen is the limiting reactant while oxygen is the excess reactant. So based on what I calculated here, let me do it back. You see that the moles of hydrogen is up 0.002, is smaller than the moles of oxygen. That means this hydrogen will finish first, then oxygen is excess. That is if the question did not give you hints on which one will finish first. But since I have hints, I don't need to pass through that stage. I'll solve straight. So I have to show you how to get it if the question did not give you. So let's go back to the question. So what volume of oxygen will be left unreacted when a mixture of 100 centimeter cube of hydrogen and 200 centimeter cube of oxygen and exploded in odometer? So we have already know that it is oxygen that will remain. So that means hydrogen will finish first. So we can now use the volume of hydrogen to know how many volume of oxygen we will get. So that is if hydrogen will finish first. So by the time you use all these 100 centimeter cube of hydrogen, how many oxygen will be left since oxygen will remain? Now you are going to start with, so you change 100 centimeter cube of hydrogen over 1. We want to change it to volume of oxygen. So to do that, I have to remove this hydrogen. Let me reduce the, so I want to change 100 centimeter cube of hydrogen gas to centimeter cube of oxygen gas. So now I'll say 100 centimeter cube of hydrogen over 1. So how can I remove this? I know that 1 mole of any substance is equal to 22400 centimeter cube of that substance. Now check from your chemical equation, here. So we have that 2 moles of hydrogen will give 1 mole of oxygen. So I can use that to switch my hydrogen and oxygen. So now 1 mole of hydrogen gas will give 22400 centimeter cube of hydrogen gas. Now centimeter cube of hydrogen gas will cancel out. So everything I have here is moles of hydrogen. So but I'm going to volume of hydrogen, volume of oxygen that will remain. So from this equation now, we already see that 2 moles of hydrogen will give 1 moles of oxygen. Yeah, so that means 2 moles of hydrogen gas will give 1 mole of oxygen gas, so that moles of hydrogen will cancel out moles of hydrogen times. Now I already know that 1 mole of oxygen gas will give me 22400 centimeter cube of oxygen gas. So now centimeter cube 22400 will cancel out 22400. Yeah, so what I have left here is 100 times 1, that is 100 times 1 times 1 times 1 again, mole, centimeter cube of oxygen gas over, so 1 times 1 times 2 times 1. So after I cancel out, so it remain all those numbers, so I'm writing the remaining numbers. So now everything here is 100 over 2, 2 here 1, 2 here 50. So what I have here is 50 centimeter cube of O2. That means by the time you will use this 100 centimeter cube of hydrogen, you will, by the time this 100 centimeter cube of hydrogen will finish, you must have used 50 centimeter cube out of this 200 of oxygen. So how many will remain now? Since I have 200 of oxygen, so excess oxygen now will be equals to 200 minus 50. So that is 150 centimeter cube. So this is the excess oxygen. So that is the volume of oxygen that will be left unreacted in the mixture. Remember, I use this 100 because it will finish first. So if this 100 will finish first, by the time this 100 finish, I must have used 50 out of the oxygen. Then it's remaining 150. So the correct answer is 150 centimeter cube.